Right, activity 1. So we're going to talk you through the first one, and then you're going to pause the video and work through the rest of the page yourself. So in this activity we've got a graph, and we're given 3 coordinates on the graph, A, B and C, and we are going to transform the graph. Now the one we've got is f of x minus 2. So let's go for the description first. How would you describe f of x minus 2? What's that doing?
Well, it's outside, isn't it? So it's outside, so we are looking... Oh, down there, right, okay. So it would be
Shift?
shift,
I think shift is the word that's usually used.
f of x,
Yeah, which way? Up, down, left, right?
down,
Down, yeah.
because it's minus
2 units.
units.
Yeah, you can just say down 2 or down 2 units. So that's one way of thinking about it, the description. So we know what's going to happen to the graph. And so if we're going down, up and down, what's going to change, the x or the y?
The y.
Yeah, so this might be the point 5 minus 1. This is the point 5 minus 3. It's gone down. Anything moving up and down maintains the same x coordinate. So y is going to change, and what we're going to do to the y?
Take negative.
Take 2 from that. Okay, so you should be able to fill in what the new coordinates will be.
So x stays the same.
Yeah.
So then that's minus 2
Yeah.
there.
X stays the same. X stays the
And
same.
then 6 minus 2 is 4.
Excellent. Okay, and now you can do a little sketch of the graph. So you can think of it in 2 ways. You can look at the original graph and move it down 2, which is what you're thinking, and then you can make sure that your new coordinates are slightly to the right, I think, because it's 1, 6.
Oh, 1, 6.
Yeah. That's it. And then
That's
label your new
A,
coordinates.
C. Would you do anything to mark them?
Yeah, you have to put the new coordinates on your actual sketch.
Minus 2, minus 2.
Yep.
1, 4.
Perfect.
3, minus 2.
Yeah. And it's a really good idea. This is going to sound really stupid, and I know that only 2 people in the class will actually do it, but they're the best 2 people, to be fair. To look at your sketch when you've done this and just think, is that where that coordinate lives? Because every time I mark a set of papers, someone will have got a graph looking like this, and then they'll label this something like 3, 2. Now either the graph is correct and the coordinate's wrong, or the coordinate's correct and the graph is wrong, because that can't be 3, 2, because it's a long 3, down 2, not up 2.
Yeah.
So this coordinate is mislabeled, so something's wrong. So it's a good idea is to just think, could that be 1, 4? 1, 4, yes. Could this be 3 minus 2? 3 minus 2, yeah. And it sounds really like a simple thing, and I know most people won't bother, but it is a good tip. Could this be minus 2, minus 2, minus 2, minus 2? Yes. So just make really sure with your graph sketching that you've got that accuracy. Okay, pause the video now and have a go at the next 2, and then when you're ready, unpause the video and we will start you off on activity 2. So, activity 2, we are going to sketch a graph, and in this case we are just given the equation and we're going to think through how to sketch it. Okay. So, what was the original graph in this case? Is it x squared, x cubed,
well,
or 1
x
over
squared.
x squared? So we know what roughly the shape.
Yeah.
Okay. Which type of transformation has happened? It's an outside one clearly, so it's outside. Is it a times? Is it an add or subtract, or is it a flip?
Well, it's just whichever one matches the pattern, right?
Exactly.
So it's the middle one.
Yep, it's this one.
Yeah.
Something has been added or taken away from it. How would you describe it in words?
Shift the graph
Excellent.
down 2 units or down 2.
Down 2. Yep, exactly. So now we should be able to sketch the graph. We know what shape it's got and we know it's gone down 2. Yep.
And then, well, we could label that one.
Yeah, we label it really obvious points like the y-axis always, yeah. Perfect. Yeah. The tip for drawing quadratics, yours is really good, is to make sure you don't do this shape. This is the most common wrong shape that students do for a quadratic. It's not a U, it doesn't go vertical, it's more like a shallow bowl really. It's much more like that second graph than this one. Avoid this at all costs. This is a really bad way of drawing a quadratic.
Yeah.
And then the turning point is the bit that's really important, the bit that you can label and see where that turning point's gone from the centre. Excellent. Okay, so pause the video now and work through the rest of activity 2, and then when you're ready, unpause the video and we'll start you off on activity 3. Activity 3, we've got another graph given to us. In fact, it's the same graph as before. So you know what to do. Have a go at describing it and then think about what's happening to those coordinates.
Okay, well it's inside this time.
Yeah,
So we're going to shift
yeah.
still. Which way are we going now? Okay, so it's -2, so we're actually going to go right.
Yep,
Shift right 2 units.
perfect. So what's happening to the coordinate? Which coordinate's going to change?
The y, x.
The x coordinate, yeah. Because, for example, if we're going from here to here, this might be the point 5 minus 3, this might be the point 10 minus 3, but the y coordinate hasn't changed, it's only the x coordinate that's changed. So what we're going to do to the x?
Add.
Perfect, do the opposite of what it says.
So that one's going to be 0 and that one doesn't change.
Yep, y coordinate doesn't change.
3 plus 2, 5.
Yeah,
1 plus 2, 3.
yeah. So, and the y coordinate doesn't change. So now you can draw it, think of it as a shift right 2, and you know what the new coordinate's going to be.
Shift right 2. So that one is going to end up there.
Yeah, that's
That one's
important.
going to end up there, and that one is going to end up.
Oh,
71. Is that it?
yeah,
So it's something.
perfect. And then you label the new coordinates.
0, 3, 6.
Yeah. Now I'm not sure if a fussy examiner would say that your turning point is not actually on the origin.
To be fair, we're using a whiteboard. It's
Yes,
not-
well, excuses, excuses.
Okay then. All right, put a pen down. Put a pen down. Yes.
There we go, there we go. Beautiful.
Unfortunately, you can't do that in an exam. but
That is a
we
good
have
point,
the-
yeah, that is a good point. But it is, this is what I was saying before, does your coordinate match your picture? And strictly speaking, you wrote 0, 0, but if you looked at your graph, your turning point wasn't on the origin, and you could lose a mark for that, depending on how fussy the examiner's been. You could lose a mark for that not being on the origin. It is really important. Okay, so pause the video, work through the rest of activity 3. When you're ready, unpause the video, and we'll start you off on activity 4. Activity 4, back to these questions, thinking through what we're drawing and how to draw it. So what have we got here? A quadratic, a cubic, or a reciprocal?
We have got a cubic.
We
so
have.
power of 3.
So we know that it's going to look like that shape.
Yes.
Okay? And it's an inside transformation,
Well, matching the shape again, so it's going to be the middle one.
middle one, which we know moves the graph left and right, shifting. So it's a shift right or left?
Left this time.
Left, because it says plus, so we do the opposite, and it's going left 1. Yep. So you should now be able to sketch the graph. So you know the shape, and you know it's gone left 1.
So the turning point is now going to be minus
Yep.
1.
Beautiful. And labelling? Excellent. Perfect. From left 1, fantastic. Okay, pause the video, work through the rest of activity 4, and in the same way, and then when you're ready, unpause, and we'll start off on activity 5. Okay, we've got similar to the last one here. It's just, I think on this one, they're not all inside or all outside, so you have to really think how it's been transformed. So the original graph's fairly obvious.
Yeah. Cubic.
Yeah, which means that we know that it's originally that sort of shape.
Mm-hmm.
So we know what we're starting with. Inside or outside?
It is outside, so
Mhm.
it is going to be this one here.
Yeah, which moves the graph, how?
Shifts it.
Yep, shifts it.
Shift up to.
Up to, perfect.
Because it's
Yeah, so we know what the original graph looked like. We know it's going up to, so it should be fairly easy to draw. Excellent. Fantastic. 0 to 2. Very good. Okay, pause the video, work through the rest of activity 5 in the same way, and then when you're ready, unpause the video and we'll start you off on activity 6. I think this is the final activity, activity 6. So we've just got the same as before really. I just think it's now going to be a mixture of inside and outside, so you've got to think carefully what to do. So can you do this one on your own?
Right. Let's describe the transformation. So it's inside the graph, so it's going to be a shift, but it's positive number, so it's going to be left 1.
Excellent.
So what's happening is the x-coordinate is changing because we're going left and right.
Mm-hmm.
So our y-coordinates don't change.
Excellent.
So I'm just going to fill those in for a minute.
Yeah, it's a good idea to do
6.
that. Yeah.
So then we're going left 1. So minus 2 becomes minus 3.
Yeah, I think it's a good idea to kind of make a note to yourself, like, what are we actually doing? Is it x or y? So it's x, and what we're going to do is take 1 off it. And just adding is notoriously difficult. Yeah. So if you've written x minus 1, then it's really clear in your head what you're doing.
So then 3 minus 1 is 2.
Yeah.
1 minus 1 is 0.
Excellent.
So if I had to sketch it, which I didn't, but I do, where are my points? Well, I've got minus 3, 0, 2, 0, and 0, 6.
Excellent.
So the graph has done that.
Yeah.
And that one is minus 3, 0, there's 0, 6, and there is 2, 0.
Excellent. Fantastic. Okay, so pause this and then work on the rest of activity 6, and then I think we're done
So don't you
on
need to
graph
pause it?
sketching. Don't even need to pause it, you just stop it.